We are going to practice solving a problem of Chapter 5 related to the use of standard temperature pressure conditions. This is problem C. Please take a few minutes to read the problem, understand what is being asked, and then attempt to solve the problem before looking at the answer that I will be posting shortly. The plan to solve problem C consists first of writing a balanced equation for the release of oxygen gas from hydrogen peroxide. Then we can use this expression or the ideal gas law to calculate the moles of oxygen gas that had been produced. So let's begin. So the production of oxygen gas from hydrogen peroxide can be represented as the decomposition of hydrogen peroxide into water plus oxygen gas. If we balance this equation, we will notice that we need to add a coefficient of 2 in front of hydrogen peroxide and 2 in front of water. And that balances hydrogens, 4, 4, and oxygens, 4, 2, and 2 is 4. So the next point that we have to do is to try to figure out how much gas, oxygen gas, is being produced. So here we have a volumes of oxygen gas equal to 20. Let's recall that from the description of the problem, this is so-called concentration. And we also know that we have 0.100 liters of solution. So to come up with amount, we usually multiply volume times concentration. Let's do that for the expression that we have here. So if I multiply 20 times 0.100 liters, that's going to give us 2.00 liters of oxygen gas. Now we can use the ideal gas law, PV equals nRT, and solve for N. Let's see what information we have available. The volume of gas is 2, we just calculated that. The pressure is 1 atmosphere. The temperature is 0 degrees Celsius or 273 Kelvin. And then if we basically solve for N, we should be able to get the number of moles. Which is 8.92 times 10 to the minus 2 moles of oxygen. Now, the next step is to change that number of moles of oxygen to mass of hydrogen peroxide. And for that, we're going to take into account the stoichiometry of the reaction that we just saw in the previous slide, which for simplicity, we'll say that we have 2 H2O2 aqueous into 2 H2O liquid plus O2 gas. So again, if we just take into account the stoichiometry of this reaction, we take the number of moles that we calculated from oxygen. We know that based on the reaction, we have 2 moles of H2O2 per 1 mole of oxygen produced. And now we are going to add a factor corresponding to the molecular mass of hydrogen peroxide. And that leads to 6.071395, which by rounding off is equivalent to 607 grams of H2O2. This is the answer of problem C.